So this is my hand-in number 5, and here we are to create like a package with a header file and a C++ file, and then we are to have function in it that can bubble sort, insertion sort, selection sort, quicksort, and binary tree sort. So first I will show you how my program works, and then I'll go through the different things. So if we start out here, we have a choice of 6 different things. We can bubble sort, insertion sort, selection sort, quicksort, binary tree sort, and we can exit. So if we take bubble sort first, we can choose 1, and then we can choose to solve letters or numbers. So if we try and solve numbers, then we can choose a length of our array, and let's just say we want 10 numbers, and then we can use random numbers, or we can assign numbers to our array ourselves, and I want some random numbers, and then we can choose to sort it low to high or high to low. I'll sort it low to high, and then we have our array with our sorted numbers here. And then again we have a new option. So if we for example take a bubble sort again and then take letters, and say we want 15 letters, and we want some random letters, and we want it to solve from low to high, then we get 15 random letters here, which is sorted from A to W. So let's try insertion sort this time, and let's try with the numbers, and let's say 15, and let's say we want random numbers, and we want from high to low. So we get numbers from 15 to 0 sorted from high to low. And let's try an insertion sort again, but this time with some letters, and we want 5 letters, and we don't want some random letters, so now I'm entering 5 letters. And I want to solve from low to high, and here we have our letters sorted. And let's try selection sort, and just random numbers with 10, and from high to low, and here they are sorted. And let's try quicksort, and I want numbers again, and I want 20 numbers, I want random numbers, and I want from low to high. So here we have 20 random numbers. This is some debugging, it should probably be commented out. So just ignore this part here. Okay, and let's try well, a quicksort again, but with the letters, 10 letters, random letters, low to high. Then we have them here. And in the end, let's try a binary tree sort with some numbers, 40 numbers for example, from low to high. And here we have 40 sorted numbers from low to high using binary tree sort. Let's just exit. And so this is programmed, and this is what what it can do. So let's take a look at the code. Okay, so first thing in the code, we use IO stream, we include that. Then we include our sorting function .h, so we can pull our functions from our sorting functions file. Then we include our create array.h, because I also made a package that can create arrays for me, so I don't have to do that all the time. So first we have our main function, and we have a integer called size and integer called choice. And size is the size of the array that we choose, and choice is well, that's which of the first 6 choices that we want to do. Then we have a do while loop that runs until choice is not equal to 6, because if choice is equal to 6, then we'll just exit the array. Exit the loop. Then we have a cout, and we see out what we need here. Then we have some integers, and some characters, and these are for the different switch statements. For example, our bubble sort choice is a switch statement that needs an integer, and our bubble sort number choice and our bubble sort letter choice, also integers. Then we have a character for bubble sort letter random and bubble sort character random. These are y and n, so they need to be chars. And we have the same with the insertion sort and with the selection sort and quicksort and binary tree sort. So then we get our input from our choice, which is our integer from up here. And then if the choice is 1, then we will have our bubble sort, and we will start out by asking if you want a number or a letter. Then we will have, you can choose here, and then if you choose number 1, then we will be asked to enter the length of our array, which is the size. Then we'll create the array of size. Then we will ask if you want random random numbers, and if you do want random numbers, we will run the function random number array. And it needs 2 parameters. It needs the array, which is from up here, and it needs a size, which is what we just inputted. If we don't want, we will run another function called number array, which also needs the array and the size, and this will just instead of creating random numbers, it will plug in from our cn function. And I'll go through later on what the number array and random number array, how they work. Then we have a cout again, if we wanted to sort low to high or high to low. And if you choose 1, we will call sort number low to high with our array and our size. And if you choose 2, then we'll sort our number from high to low, again with array and size. And when I go through the sorting functions, .h and .cpp file, I'll explain how these functions work. And then if you choose number 2, this is then if you want characters, and you can choose the length of the array again, and you can choose if you want random numbers or random letters. And if you choose yes, then we call another array function, which is random char function, or random char array. It also needs the array and the size. And if you choose n, then we will just have char array, which we will input our characters using cn. And we can choose how to get it sorted, and it's a different sorting method if it's characters or well, it's not really that different, but since the array is a char array and not an int array, we need to make a few things differently. So we have a different function for each of them, and here we can sort char low to high and sort char high to low. And both for parameters need the array and the size. And if we choose number 2, we can have insertion, and this code is essentially the same. We ask if we want to sort letters or numbers, and we ask if the length of the array. We create the array with integers. We populate the array with random numbers or with input numbers, and then we sort it using insertion sort num low to high or insertion sort num high to low. And they also need the array and the size. And then if we want characters, we create a char array, and we populate it with random or with cn, and then we can choose to sort from low to high, high to low, using insertion sort char low to high and insertion sort char high to low. And the selection sort is essentially the exact same thing again. We go through, ask if we want random numbers, the length of the array, how we want the numbers sorted, if you want letters, if we want random letters, and how we want the array sorted. And again, our parameters for our sorting functions are the array and the size. And with Quicksort, it's a bit different. Still, we ask if you want numbers or letters, and we ask the length of the array, and if you want random numbers. But when we need to sort it from low to high or high to low, our Quicksort function is a bit different. We need the array, and then we need our leftmost position in our array, which is 0, and then we need the rightmost position in our array, which will be size -1, since it goes from 0 to, for example, we can see here if our array is 2, 1, 3, 4, then we will have the first position will be 0, and the next will be 1, and then 2, and then 3. So our length is 4, but we want this number here, so that's length minus 1, because then we will always get this number here, and the first number is always 0. So that's the parameters for our quicksort, and it's the same parameters for characters. Then we have our binary tree sort, and it's the same as this is the same as the selection, insertion, and bubble sort. We need our array and our size, and we do that for the charge 2, the array and the size. Then we have case 6 called exiting, and then we have a default which will just be choose 1 to 6. So if you press 7, it will ask for this. And this is essentially my main function, which just calls other functions from other documents. So if we look up here, we can see that I have my main document. Then I have my sorting function.h, sorting function.cpp. Then I have my create arrays.h and my create arrays.cpp. And in my main, I include these 2 header files, so I'm sure I can use my functions later on. So if we go through create array first, we have 4 function initialized here, and we include time because we want to use srand. So we have a random number array, which needs a parameter of an integer array and an integer size. And for our number array, we need an integer array and an integer size. For our random character array, on the other hand, we need a char array and an integer size. And for char array, we need a char array and an integer size. And in our CPP file then, we start out by saying, okay, if we call our random number array, we will have an integer array and an integer size. Then we will use srand with an unsigned int and a time of null. And then we'll just say, okay, we will run for loop populating the array from I to size. And while array I is equal to rand, and then we want numbers from 0 to that size. So if our number is, for example, 10, we will have number from 0 to 9. And if we want to populate it ourselves, we can use first I use stdcout and enter your 5 or 6 or 7 or how many numbers you have in size, and then I run a for loop, and we use cn to get a number, and then we populate the array with that number. And for chars, it's almost the same. Instead of just having a random number, we want a character, but we want a random number from 0 to 26, and then we will plus it with the a, because the character a is ABC also have numbers. If you so the first number a has, or the first letter a has a number of 26. So if random function is 0, then we will get an a, but if it's 1, then we will get a b, and if it's well, then it continues all the way up to 26, and then we'll get the last letter. And for us char array, where we input with cn, it's just a char instead of an integer, and we get that in, and we populate the array. So that's our create array functions, and they're pretty neat to have, so we don't have to call them all the time. So let's take a look at our sorting function.h. And first we have an explanation of how you use the the header file here. It explains what you need to which parameters you need to give the functions and how they work, both for bubble, insertion, and selection sort. That's kind of the same for all of them. Then for quicksort it's differently, and for binary tree sort it's also a bit different. Then we have an explanation of what the different function does. We have 20 functions in all. This is because we have 5 different sorting methods, and we have 4 different sorting methods in each. Or ways to sort. We can sort number high to low, number low to high, char high to low, and char low to high. And this we can do for all 5 of them. So the first thing I do is I create 2 functions called swap, and I'm creating these functions because in some of the sorting methods I need to swap 2 numbers, and the easiest way to do this is to create a function that you can just call, so you don't have to use to make temporary variables all the time. You could, for example, normally you would make a temp, and then you will put that equal to, for example, A, and then you will see A equal to B, and B equal to temp. But this takes up a lot of space all the time, so if we just have a swap function that have this in it, then we can just call swap, and then, for example, number A comma B, and then this function here will actually swap using what we just made over here. So it's a lot easier to do this way. Okay, so let's see. Yeah, so let's first go through how the swap function works, and then we'll go through how bubble sort works, how insertion sort works, selection sort, or quicksort, and how our binary tree sort works. It's just one function for each in bubble sort, insertion sort, and selection sort, but in quicksort we have 3 functions for each of them. We have one that displays the numbers, one that sorts the numbers, and one that splits the array. And the same we have for chars. And for binary tree sort we have our struct with our node in it, both for our characters and for our number. Then we have we have the function that sorts it, and then we have the function that inserts the number into our tree, and the function that prints the number from our tree. Combined for all of them is that when you run this function here, or when you run any of the functions, it prints out the number afterwards. So it's built in to the function that will print out the number. So if we take a look at our swap function first, as I explained before, you can see that this is just very easy. We have an integer with a with our reference operator for A, and an integer with our reference operator for B. And then we create an integer called temp, and then we swap A with B. The same with our character. And it's a very easy function that's always nice to have if you are swapping things a lot. So if we start out with our bubble sort, we have a sort num high to low with an integer array and an integer size. And this works this way. We have a for loop that runs from 0 to our size minus 1, and then we have a new for loop that runs from j to j, which is I plus 1, to j less than size. And then we check if our array I is less than our array j, and then we swap them, and then we print them out. And this can be illustrated if we, for example, take a look here. If we have an array, for example, 3, 2, 4, 1, then we can say, okay, first we say that I is equal to 0, because this is our for loop here that says, and then j will be I plus 1, so the good thing is that j is then 1. Then we test if array I, which will be 3, so it's equal to 3, and array R, yeah, that's equal to 2. So if array I is less than array j, we swap them. this is not the case, so we will not do that. So then we will run it. Then we will run the next. So j will be one more. Oh, so we will say j is now instead of 1, it's now 2 because we have j++, and then array I will still be 3, but if we look over here, we will have number 2, that's 4 here. So if 3 is less than, and remember we're sorting from high to low, so if 3 is less than 4, then we'll swap them, and it is. So our new array will be 4, 2, 3, 1, and then let's just get this away. Okay, and that's it. So we can say, okay, well then this will be 3, because our size is equal to 4, so this will go up to 3. And then we'll say, okay, j is now equal to 3, that's 1. So then we'll have here, and is 3 less than 1? Nope, it's not. So we will say, okay, well then we are finished with that for loop, and we will go up to start 1 will go 1 up, so it's now from 0 it will go to 1, and the next one will start up on 2 because j is I plus 1. So what can we do? What can we say now here? We will have array I will then be 2, and array j will be 3. And is 2 less than 3? Yes, it is. Then we'll swap them. So it will say 4, 3, 2, 1. And now we actually have our array sorted, but we're not done with our for loop. So we'll run our for loop again and say, okay, this will then be 3. And then we will have 1 here. And then we'll say, is array I less than array j? No, it's not. So we'll not swap them. And then this will go up to 2. And yeah, since it's sorted, it will just run through and check, and it will not swap anyone around because it is already sorted this way here. So that's quick, easy how we how our bubble sort works. And if we look at the low to high, it's just instead of less than, we have more than or bigger than. And in the end, we print it out using std_cout, and we print the array and with a space. And for our character, it's the exact same, because our character actually has well, it kind of has a number each character from 26 and upwards, incrementing 1 each time. So we can again say less than and more than. So let's take a look at how insertion sort works. It's a bit different, but let's take a look at it a bit more graphically. If we go through the code first, we have a for loop that runs from 0 to the size, and then we have 2 temporary values, which is a temp and a place. And our temporary value first is our first number in our array, and our place is well, the first number minus 1. And then we check if the place is bigger or equal to 0, and if our array and then our place is less than our temporary value, which is our first value. And if it is, then we will say that our array place plus 1 is equal to array place, and then we will say place minus minus, so it will minus by 1. And then we will do that until the statement is not true. And then we'll say, okay, well, array place plus 1 is equal to our temporary value, so we change that around, and then we'll run the for loop again. So let's see how it works. And so if we, for example, first we have our I, or well, let's create an array first, just so we have one. Let's just say 3, 2, 4, 1. So our size, oh yeah, is equal to 4, and I starts out at 0, and then temp array I, so temp is equal to our array with our index I, which is number 3, and then our place is equal to I minus 1, so I is 0, so that's minus 1. And then we check out while our place is larger or equal to 0. Well, that's not really true, since it's minus 1. So the while loop will just stop, and then we'll say, okay, array place plus 1, place, that's this. So now, well, array, or it's probably easier if we just say place plus 1 is equal to 0, and then array 0 is equal to temp, and that's already what we have up here, so I'll not rewrite that. Oh, sorry. But we can now say that our 0 is now 1 larger, so instead of 0 it's now 1. And then we can say, okay, well, temporary is equal to array I, which will now be 2. So instead of 3, we will just erase that and say, okay, well, it's now 2. And our place is I minus 1, so instead of, so that's I minus 1, which will be 0. And now we have some numbers that we can better work with. So place is larger or equal to 0, which is true. And array place, if we say array and place is 0, that's equal to 3. Is that larger than our temporary value, which is 2, or smaller, sorry, smaller than? Nope, it's not smaller. Okay, well, then we'll say, so we will say array place plus 1, and we know that place is 0, so that will be number 1. That's equal to temp, which is 2. So that's actually where we just say this is equal to 2, which will it already is. But let's try and run it again, and we can say that we're again sorting from high to low, by the way. So let's say that I is now 1 more. So we'll have I is equal to 2. And then we will have temp is equal to array I, and array I is 4. So temp is equal to 4. And then place is I minus 1, so that's instead of 0 it will be 1 this time. And then we will have place is larger or equal to 1, which is true. And array place, we now have 1 in here. Let's just erase these thingies here. We will have array place, that's 1. That's number 2 up here. It's less than temp, which is 4. And, well, this is true. Okay, well, array place plus 1, which will be array place plus 1, that's number 2, is now equal to array place. And array place and place is 1. So now we take the number 2 spot, which will be this spot here. No, oh sorry, will be this spot here. That is now equal to this spot here. So our array will say 3, 2, 2, 1. Then we will say place minus minus, which will be 0. Then we will say array. Then we'll check if place is larger or equal to 0, which it is, and then we'll say array place, which will be 0 this time here, and array 0, that's number 3, is 3 less than 4. Yep, it is. Okay, so we will say array place plus 1, which will be just place plus 1 will be number 1, and array place is 0. Okay, so number 1, which is this place here, will be equal to this, so it will say 3, 3, 2, 1. Now I will say place minus minus, which will be, instead of 0, it will be minus 1. Now our place is not higher or equal to 0. Okay, then we say array place, so we can say array place plus 1. Place is now minus 1, so plus 1, that's 0. That's now equal to temp. And we know that temp is 4, and array 0 place, that's this spot here, is equal to 4. So our array will now be 4, 3, 2, 1. This is now our finished array, and it's sorted from high to low. What we are doing is that we look through our array for first we've looked through our array for numbers, then we check if any of the other numbers are larger than it, and then we exchange these numbers. So in the end we get this nice array here, and then we print it out. And we do the exact same thing for high to low. We just use we only change a few different values here. You can easily see it here. Well, we change a few things. For example, we have I instead of I minus 1. We have places larger than 0 instead of larger and equal to 0. And we have array place minus 1. Is larger than our value. We have value instead of temp. Yeah, I did these two in 2 different days, so I may have not given them the same values or the same names, but that doesn't matter. But let's run through it again here on paper, just to see how it works. So first we have an array, and let's call it 3. We're starting from low to high this time, by the way. So 3, 2, 4, 1. And we have a value, and we have a place, and we have an I value, and that's it in the beginning. So I starts on 0, and value is array I, so that's 3, and then place is I, which is 0. Then we check if place is larger than 0. Well, it's not larger than 0, so yeah, we can't really do it. So we will say that array place, that's number 0, is equal to our value, which will be 3. So really what we're doing is we're taking number 3 out and putting number 3 in, so we'll have the same array. So we run through it again, and we change our values. So let's go through it here. Let's see that we have an I value. Instead of 0, it's now 1. And our value is array I, which will be 2. And then place will be 1. And then we say place is larger than 0, which it is. And array place minus 1, which will be array place is 1 minus 1, which will be, well, 0, is larger than our value, which is 2. Number 0, which is number 3. So this is correct, because that will have 3 larger than 2. Now we can then say, okay, well, our while loop is true, so array place, which will be place is 1, which will be number 2 spot here. This has to be equal to array place minus 1, and array place minus 1 is 3, so we will say 3, 3, 4, 1. Then we'll say place minus minus, so place will be equal to 0. Then we'll say, okay, is place larger than 0? No, it's not. It's 0, but it's not larger than 0. So array place, which will be this spot here, is now equal to our value, and our value is 2. So our array will then say 2, 3, 4, 1. Okay, so let's clean this up a bit before we continue with our next, before we take next step in our for loop. Okay, let's see here. I'll just put the array up here again. So let's just say our array is 2, 3, 4, 1. Okay, so instead of 1, our I is now 2. And by the way, it goes from 0 to less than size, and our size, we haven't really written it up here, but size is equal to 4, so it can go up to 3. So let's say that I is equal to 2, and then we will have value is equal to array 2, which will be number 4. And then we'll say that the place is equal to I, which is 2. Then we'll say is place larger than 0? Well, it is. Array place minus 1. Place is equal to 2, so that will be 2 minus 1, which will be 1. And array 1 is 3. Is that larger than our value, which is 4? No, it's not larger than our value, so we will kind of break our while loop. Then we'll say array place, and place is equal to 2. That's number 3 spot here, is equal to our value, which is 4. So our array will then be 2. No, sorry. Yeah, array 2 is equal to 4, and 4 is our value. Yeah, never mind. I was just thinking this was weird, but it's not. So we will exchange this value with 4, but it's the same value, so we will not change anything. Then we'll go one more up, so we'll say that the I is 3. Let's just clean this up. So I is now 3, which is our last step in our for loop. And place is also equal to 3, and array I will be our value is now 1, because, well, array I is 1. And then the place is larger than 0. Well, yes, it is larger than 0. And array place minus 1. 3 minus 1 is equal to 2. And this number 2 spot is 4. Is that larger than our value? And our value is 1. Yep, it is larger. Okay, well then we'll say array place, which will be our spot here. That will be equal to our array place minus 1, which will be our spot here. So now we'll say our array is 2, 3, 4, 4. Okay, well, let's just say array place, place minus minus. So now our place is, instead of 3, it's 2. And the place is still larger than 0, and array place minus 1 will be that will be 2 minus 1, that's 1, and number 1 spot, that's that's 3. Is that larger than our value, which is 1? Yep, it is. Okay, so we say array place, and array place, that's 2, that's number 3 spot, is then equal to our number, that this spot here is now equal to our number 3. So our array will be 2, 3, 3, 4. And then we'll say place minus minus, so place is now 1. And then we will say, okay, place is larger than 0, and array place minus 1 will be, check it out down here, that's then 1, which will be 0. It's larger than value, which is 1, so that's number 0, that's 2. It's larger than 1, yep, it is. Okay, then we'll say array place, which is this spot here, will be equal to this spot here. So it will say 2, 2, 3, 4. And now we'll say, okay, place minus minus, so place is now equal to 0. And then place is not higher than 0, or bigger than 0. And then our while loop breaks, and we can say array place, which is this spot here, is now equal to our value, which is 1. So our array will be 1, 2, 3, 4. And we have sorted it from low to high. And this is the same way as we did it with high to low. It's just some of the values are a bit changed because we need to go from, instead of plussing with 1 all the time, we need to minus with 1 to get the previous spot in the array instead of the next spot in the array. And doing it with characters is the exact same thing. It's just instead of integer array, we have a character array, but else the formula is the exact same thing. So let's take a look at our selection sort. And well, in our selection sort we use our swap function. So let's see here. First we have a for loop which goes from 0 to size minus 1. Then we have a temporary value called max. We sort again from high to low, so we have a max value. And we set our max value to 0 in the beginning. And then we check out again in a for loop that goes from I plus 1 to well, until that's less than size. And then we check if our array j is larger than our array max, and if it is, then max is equal to j. And then we make sure that max is not equal to I, because it is this in the beginning. And then we swap them if this is not true. This is just to be sure that we are not swapping when we shouldn't, because that can cause problems. So if our array j is larger than our array max, then we'll swap them out so they are in the correct spot. So let's take a look at this a bit more graphically. We have an I. Oh, first let's just take an array first, and we sort from high to low. So let's say 3, 1, 4, 2, and our size is equal to 4. So we will have an I value, we will have a max, then we'll have a j, and that's it. So first I is equal to 0 and max is equal to I, and j is equal to I plus 1, so that's 1. Good. So let's run through this. If array j, so let's say array j is larger than array max, and array j, that's 1, and array max, that's 0, that's 3. 1 larger than 3? No, it's not. Okay, well, we will plus 1 more up, so now j is equal to 2. And then we will have some other values down here. We can say that array j is now equal to 4, because we have the second spot, 0, 1, 2. It's equal to array max, which is 3. 4 is larger than 3. Well, that's true. So our max value is now equal to j. So max is now, instead of 0, it's 2. And then we run our for loop again, going plus 1 up, saying okay, let's check which is now our largest value, because we're going through and checking what is the largest value. And our array j is now 3, and we say that's 2. Oh, that was really ugly too. And let's say that 2 is larger than array max. Array max is equal to 4. Well, that's not true. Okay, well, we will break out, and our for loop is now at this maximum point, which is 3, because 3 less than 4 and 4, well, this is not correct, but this is the spot we're at now. But if we increment one more time, we'll have 4 less than 4, which is not true. Oh, that was not a good eraser. So now we can say that is max not equal to I, and well, that's correct, because 2 is not equal to 0. And then we can swap array I and array max. So let's say array I, this is this spot here, and array max is this spot here. So we will have a new array saying 4, 1, 3, 2. Now we have gone through the array, found the largest point, and swapped it to the beginning of the array, because we're sorting from high to low. So what we can do now is that we can erase some of this stuff here. Oh, yep. Then we say, okay, I is now, it's not 0, but it's 1. Okay. Now I'll just write the array nicely up here, so we have it. So we'll have 4, 1, 3, 2. And now we know that 4 is in the correct spot, so we can go one more up. And max is now equal to 1. And let's say that j is now I plus 1, so that's number 2. And array j is number 2, that's 3, is larger than 1, or array max, which will be 1. And this is true. Okay, so now max is I equal to j. So then max is equal to number 2. Then we check again. Okay, j goes one more up till 3. So array j, which will be 2, is that larger than array max? Max is 2. Oh, sorry, array 3. Oh, yeah. And array 2, that's 3. Nope, that's not true. Okay, well then we check if max is not equal to I and max is not equal to I, then we can swap I and max. So array I, which will be this one here, and array max, which is this one. We can swap those. So our array will now be 4, 3, 1, 2. So now that we know that our array, we now know that our spot number 0 and 1 are in the correct positions. So we can increment the I to be 2. Because now it will start with this position and check if it's larger than this one. So max is now equal to 2 and j is equal to 3. Then we can say array j, which is 2, is larger than array max, which is 1. This is true. Then we can say max is equal to j. So max is equal to 3. And then we can not go one higher up for our j value because 3 is less than 4. And we cannot go higher. So therefore we can check if max is not equal to I. Max is not equal to I. We can swap out I and max. So we swap out this with this. So we say our new array is then 4, 3, 2, 1. And we sorted it from, well, high to low. And this is our selection sort. Just an easy way to do it. And if you check our low to high, this is almost the same. It cannot be more the same. Instead of a max value, we have a minimum value. It could just have been called a max value, but I chose to call the minimum just to make it easier for myself. And then we just exchange more than for a less than. And that's it. There's nothing more to it. So let's... that was our selection sort, so let's take a look at our quicksort. I had some problems with the quicksort. My main problem is that every time I try and run it through on pen and paper, it will not go the correct, which is a bit of a problem. But I suspect that I cannot keep track of all the recursive functions on pen and paper. So, well, let's try and run it through here in the code and see how it what it looks like. So first, then we have some parameters. We have the integer array, the first and the last. So if you remember, our array, for example, can be 3, 1, 2, 4, and our first was 0, and our last will be size minus 1. Since we have size equal to 4, so our well, let me write this nicer. First is equal to 0 and last equal to size minus 1, which will be 3. Okay, and then this function is actually just printing out the array to display it. This, but I had a problem passing the array from one document to the other, so therefore I'm just displaying it out here. And I need a size because the next one, or to print the array out, I need the exact size of the array because else I'll just print out the 3 first numbers, but I kinda want to print all 4 of them out. So my size is last plus 1, and last is equal to 3, so size is now equal to 4, which is also what it is up here. My quicksort low to high, it needs the array, which it's just an array. And then it needs the first and last, which is exactly what we passed from up here. So let's take a look at our quicksort low to high function, which is just down here. So what we want to do here is that we want to have a pivot point, and that pivot point we can choose in different ways. To make it easy, I chose the first element in the array as a pivot point. That means if we have an array called 3, 2, 4, 1, I chose this as our pivot point. If we, for example, look at the choice of pivot point on the Quicksort's Wikipedia page, we can see that it's recommended to use first plus first plus last divided with 2 as a pivot point. This will create, for example, if we take here, first is 0, last is 3. No, last is last is 3. Yeah. So therefore we'll have plus 0 plus 3 divided with 2, and this will be 1.5. But since we're using that's a 3, 1.5. But since we're using integers, it will be 1. So this will be our pivot point here. I chose not to do this because I think it's way easier just to use the first part. Okay, so I choose a pivot point PP to be 3. Good. Then we need a split point where we split our array into 2 parts. First, I always check if my first or if my last is larger than first. Since first equal to 0 and last equal to 3, I will have that my last is larger than my first. So this will be true. Then I'll take my split point, which we'll call SP, and I set that equal to my split number low to high array. This is a function that splits my array into 2 parts and sort kind of each part of them. I do this so first I pass my array, which we have up here. Then I pass my pivot point, which is 3. Then I pass my first and my last. And this is because my function needs those 4 parameters. So let's take a look at the function for this. And here, in the beginning, I redefine some numbers. This is just so I don't confuse first and last from the first function to the next function. So I call them left and right instead, because first and left, this is the most left, and this is also the first, and this is the right, but it's also the last. So I check if left is less than right. Yep, and since left is 0, is less than 3, which is true, then I can check if my pivot point, or if my pivot, which is also my pivot point, is less than my array right, which is this one here. My pivot point is 3, and if that's less than this, and my left, or my right is larger than my left, which it also is, then I can say that my right is 1 smaller, and I swap them around. And then I do it kind of on the other side of the array, where I take my pivot point is larger or equal to array left, and if left is less than right, then I plus 1 without my left, and then I swap those. And then I return my left value, which will now be my split point. And then I recursively run the function where, see, this is what needed to be commented out. That's just for debugging. Then I recursively run my quicksort low to high with my array as my first parameter and my first as my first, but my last is now my split point minus 1. So if we, for example, say that the array is 1, 2, 4, 7, 6, 5, 3, then if we say my split point is 7, then I'll go and say, okay, my first point is number 1 here. This is my first, and then my last point will be split point minus 1. So this will be my last point. So now I will try and sort this part of the array here. And then I'll recursively also use my array split point plus 1, which on the other hand is this one here. And my last is now my number 3. And that means that I will sort this part of the array here. And each of those here will again take and find a pivot point and a split point, and then split those smaller arrays up. And then it will split up the array until it has the sorted array, and then it will return that. So it's extremely difficult to do on pen and paper, but it's easier to do in programming. I used the Wikipedia page a lot for the quicksort. They have some good solo code that really explains what you need to do, and it wasn't. It was hard and it was challenging, but it was doable. So yeah, that's kind of what it is. Then the array is then returned up to my quicksort number array, and then I will print out the sorted array here, and it does the same with characters and with low to high. Or this is low to high, but if I want to have the high to low, it's a matter of changing let's see. Oh yeah, here it's a matter of changing the smaller and bigger than brackets, and that's kind of it. Even though it took me a lot of time to figure out how to do it, it was really easy in the end. Well, when we had the low to high and then make the high to low, that was the easy part. It was not easy to make the quicksort. So let's take a look at the insertion sort. If we take the low to high here, oh, not the insertion sort, binary tree sort, of course. So first, in our sorting function, we define our structs here with our nodes for our number, for example. It has an integer and it has a pointer to the left and to the right. And then we say that we make a node and call it root, and we set that equal to null, so it does not have any data in it, and it does not have any left or right. Then we, in our for loop, we run for each, or from 0 to the size, and we run this function insert number low to high, because we need to insert nodes into our tree. And we have our root as our we need the parameter is that we need a pointer for our root, and we need an integer for our data. So our integer for our data is the I value in the array, which will be from 1 to, for example, 4, and the root is the root tree node we have up here. So if we take this out from, see here where we have low to high here. So first, if our root is equal to null, then this is our first node that we're making, and we make a new tree node number, and we say that the data is equal to our new data, which we just put in here from the array. So we can, for example, say that we have our root, and it's data. Let's call it D is equal to, if our array is 3, 2, or 3, 1, 2, what's wrong here, 2, 4, then we can say that's 3, and our left and right, those are both equal to null. Because we don't have anything we can do here. So we return that, and then we run this again and say, okay, our root is now equal to this here. So we will say integer number, the next one, this is our number 1. And then we will say, okay, well, if now our root is not equal to null because our root is equal to this here. So it's equal to this, all of this is our root. So now we can say that else if our new data, which is 1, is that larger than our root data? Root data is 3, so it's not larger. Okay, then we know that it's gotta be smaller. So we make our root right, which is this one here. We point that. That's now our new root that we create. So we point that with our new data and insert that. So what we kind of have is we have our root up here, which is our first node. And then we say, okay, we take the right one and create a new node here. And up here we have number 3, and down here we have number 1. And then we run this again with another number, which is number 2, and then we check, okay, well, number 2 is less than 3, but it's more than, so we can create another number, but it's also on the left part here, so that's kind of inserted in between this here, which is number 2, so we have 3, 2, 1, and then 4 is larger than, so we can have that down here. So we have like the way we have 4 to 3 to 2 to 1. So now we have a kind of 3 or 3 out of this, because we have like the branches where we have box goes down to a box, goes down to a box, goes down to a box. This can be a bit hard to illustrate, but this, if you have a lot of numbers, you can have a nice tree out of it, where you have branches on all of them, and it can start to look way more tree-like, if you can say it like that. But it's actually not that hard to make, since we just check if it's where the data should be placed, left or right, and we just place it. And then after we have placed that for all of them, we want to print out the tree. So we take our function that prints the tree, and it checks if the node is not equal to null, because we don't want the node is, by the way, that's the node that we pass, the pointer node. We check if it's not equal to null, and if not equal to null, then we print out, or we print out the left one, then print out that data, and then we print out the right one and that data. And it's again recursively, where we take this one without node to the right, put that in, check if it's not null, print it out, then we take the node to our left and check it in, if it's not null, print it out, and then we do that with all of them. So we kind of go through and checks, okay, this one, then we can go down here, this is not null, well, then we can go down here, this is not null, well, then we can go down here, oh, this is not null either, or this is null, then, and then we can go back and check, oh, this is not, this is then null, and then go back up, and this is not null, we can print out that, this is null, we cannot print it out, then this is null, we cannot print it out, and then go back again, we can print this out, we can print this out, we cannot print this out, we cannot print this out, go back. And then we go back and forth in the array and print all the nodes out, and in our tree, and in the end we have printed all our nodes in the correct order, because the branches are sorted, because we sort them while we put them into the tree, and not when we take the or well while we are creating the tree, we are actually sorting the numbers instead of just putting them in the tree and then sorting them when they're in the tree. We sort them while we're putting them in. So that's my 5 sorting methods, and it's pretty easy to use. If you just take the 2 sorting functions, drag them into a new project, and you will be able to call them using the instructions explained in the start of the header function. The 2 for create arrays, you can also just pull into another document and then just include them.